Can you all see the screen now?
Yes.
Great. This is the table of content for today's session. First, we will talk about an introduction to AI generally, then into machine learning specifically, and into deep learning. After we finish the first 3 points, you can see the difference between machine learning and deep learning. It will be very clear. Then we will discuss the difference between data science and data analysis. Finally, we will show practical use cases for daily life. And finally, speaking on AI career jobs in the past recent years. Can anyone tell me what they know about AI? If you have a background on it. If not, that's completely okay. Okay, we will jump right into it. First, I want to show you the emergence of data in the recent years, which I believe is the reason for the emergence of AI fields, specifically because they deal with a lot of data, or as you know, the name big data, since 2020 especially. The internet have been quite popular since probably 2000, year 2000, but after 2010, with the emergence of social media, there has been a significant increase in the size of data. As you can see here, with the increase of data the years, the data has grown from gigabytes to 10 power 21 bytes. As you can see, it's a very huge number. And this is what we call now big data. And this is what gave us into AI. First, we have a lot of data, which doesn't make any sense, like the data on social media. It gave us into data analysis. And from data analysis, we can conclude some data insights. And using these data insights, we want to teach the machines to learn from this data so that it can give us useful insights without having to use a human to give us these predictions. We will talk more clearly on that in the following slides. There is something important that you should know. If you are going to start into this field, you will probably have to deal with a lot of probability and statistics. That's why many people who dive into the field probably should take an intensive course into probability and statistics, not because you won't be able to apply the machine learning models into your practical use case, but so you would have a very good insight into what the model does and how it gives you correct prediction, just to have a solid background. We will talk more into this into the last slides, so we can skip it. I will first talk about machine learning. We have like this big bubble of AI, and it includes the first part we're going to talk about is machine learning. Artificial intelligence, it has a very clear explanation, like it is the engineering of making intelligent machines and program, which is quite clear from the name. But the machine learning is how we enable the machine to learn without being explicitly programmed, which means we don't exactly tell it what it should give, like in normal programming. Actually, we want it to learn that itself. And this is how we say that the machines gain intelligence, which the result would give us some predictions that we can use. What machine learning does, first starting with the data, we want to extract some features from this data. And these features, it can be something like if you have an example of images, and these images are of different animals. Then these features can be something like the edges in the image or the texture of the image. Texture means like, something like الخامة. If we are talking about clothes, like the texture of jeans is different from silk. But in images of anything, we just say that this is the texture of the image. It gives us some indication of what this image could have. Like if we have an image of an elephant and an image of a cat, they would have a pretty different textures. Anyway, extract some features like this, and then using these features, what machine learning does is trying to recognize the patterns in the image. Like what pattern recognition means in cat images, it probably have the edges image, we have the patterns of the drawing of a cat, the ears, the nose, the eyes, and etc. After learning these patterns and recognizing them, the machine learning model can then give us a prediction of what this image is or what these extracted features are. So it can tell that this image is a cat and this image is an elephant, and so on. Here is a comparison between traditional coding and machine learning. As you can see in traditional programming, if you're programming anything like a calculator, using any programming language, you have some data and you build the program such that it takes the data and gives you the output. Like if the program is a calculator, the data could be the values you input and the operation plus, minus, divide, etc. and gives you the output right away. Whereas in machine learning, you have the data and you have the output. And what you are trying to do is build the model that can map between the data to the output right away. It has already output in the first place, but what we are trying to do is given it some new data it hasn't seen before, it can give us a correct output. There are some different machine learning techniques that you would probably hear or you can use it in practical use cases. First of them is regression. When you use machine learning regression, it means that you are trying to predict some continuous value. For example, the temperature or the weather of any day. It could be 40 or 35.6. Any continuous value is valid. In classification, the second technique, you are trying to map the inputs or the data you have into different set of classes. These classes could be just a binary, like for some example, you have some data, and using this data on employees, you are trying to know if this employee would be promoted this year or not. So the prediction is either yes or no. This is a binary classification. But if you have different set of images for different animals, and you know that these images include 5 different animals, so that's a classification problem, but into 5 classes, and so on. In clustering, this is a different technique. You have some data, and you don't know what this data represent. You are just trying to differentiate between them into a set of clusters, or like مجموعة. We have, it is similar to classification, but it's just that you don't have the output. You have the set of images, and you are trying to build a machine learning model that would differ the images of cats into a category and images of dogs into a different category, and so on. But you actually don't know that this group represents a cat. You just know that this is the first group different than the second group. In trend analysis, this is actually important for fashion designers or fashion companies. What you are trying to do in trend analysis is that you have the data of like sales in the past year, 5 years, and 10 years, and so on, all the previous data that you can have. And you are trying to predict at which period of the year, for example, what the sales of this store would be trendy. This is one example for it. Like in Egypt, for example, many fashion stores have high sales before Eid, because it's tend to bring you clothes before Eid and so on. Other example for trend analysis, it can be used for weather predictions, but not for predicting the weather temperature, but like when it is more likely to rain in the year. In Egypt here we have it in winter only. For example, in other countries it is in summer, and so on. Last machine learning technique is called anomaly detection. In anomaly detection, you have again a set of data, and there are very few odd samples between these data, and you are trying to point them out. That's it. There was a small example I saw. A set of images will include an image of a fish, but all of them are looking right, except 2 are looking left. So the machine learning model could predict the only 2 images that are looking left. Because usually the edges, images, or the features of it would look different. Does anyone have any question in this part, or we can leave the questions for the end of the session? Just mark it or write it in a notebook. There is.
We can leave the questions of the end, the presentation.
Yeah, yes, okay. There is something else that we should know about machine learning. In this set of techniques, we can divide them into 2 partitions. The first partition is called the supervised learning. In supervised learning, like in regression or classification, we have the data and the output. For example, if we have these images, we know that this image is a cat and the other image is a dog. This is called supervised learning. The other division is called unsupervised learning. In unsupervised learning, for example, the clustering I was talking about, we have the data, but we don't know what each of them represent. We call it unlabeled data. But in supervised learning, we have labeled data. The output here we call the label of the input, which means cat is called the label of this image, dog is the label of this image, and so on. Now let's talk about deep learning and the difference between machine learning and deep learning. First, deep learning is considered a subset into machine learning, but it is more advanced because it doesn't need to extract the features. This should be features and not data. We don't need to extract features beforehand. This concept, or you can see the representation for it, or heard of the name neural networks, it exactly represents the neural. I'm not sure if it's called the neural networks also or not in human anatomy, but it is الجهاز العصبي في العقل يعني. The deep learning is basically something that simulates this, but into programs. Yes, it's called the neural system of the human brain. Deep learning always uses neural networks, and it's used for more complex applications, as you would see. Here is something that can show us the difference between machine learning and deep learning. If we have this input image in both cases, and we are trying to predict that this image is a core, if we are going to build a machine learning model, we have to first extract the features ourselves. Again, the features depend on whether our input is an image or a text. It depends on the input and what we are trying to do. But generally speaking, we are extracting some features of the image. Then we are going to give it into the classification model, which then will tell us that this image is a core. But in deep learning, we don't need to extract the features ourselves. We just have this input and give it into the neural network. The neural network can do both things right away. It extracts the features in an amazing way, basically, and then in the final few layers, it can make the classification and gives you the output that this image is a core. This is an image that shows the deep learning, machine learning, artificial intelligence bubble, basically, or the relationship between them. Artificial intelligence includes machine learning and deep learning is considered to be a subset of the machine learning. And as you dive deep, you get into more complex applications. By the way, the advances of deep learning in the recent year was caused by the significant amount of data in the recent years, but even more, the emergence or power in the GPUs, the graphical card in the computers, like from NVIDIA or AMD. Their significant architecture is the cause of the advances in deep learning, because before that we had a lot of data, yes, but we weren't able to build an advanced or a large neural network to apply deep learning models, because they are quite heavy. They consume the GPU heavily. Like I have on my computer a 4 gigabyte GPU, and this is considered to be small. And it can run like quite simple deep learning models. Other organizations like NVIDIA and so on, they use almost 32 gigabyte or even more. I recall Google has now a terabyte GPU, which is thousands of gigabytes. There's a lot of something else that advances of deep learning on machine learning. In machine learning, it usually wants the data to be structured or semi-structured. We will explain more the difference between them. But which means that the data should be organized in some way. It can be some messy data, unlabeled or different. We will explain it in a following slide. But in deep learning, it can deal with unstructured data too. We said this, okay. Sorry. This is the different types of data that we have. Structured data, semi-structured data, and unstructured data. In structured data, for example, it can be like the numerical data in Google Sheets. If you have an Excel sheet with data, that's called the structured data, or in databases. Because it is organized, we can label each one with a unique ID, for example. But in semi-structured data, we can have quite loosely organized data. That, again, it can be categorized, but just using the tags, not very efficiently like in databases and so on. For example, the emails in an inbox sent drafts, it differs the emails into a set of folders, but each folder doesn't represent emails of the same kind. That doesn't mean that all the emails in inbox are work emails, for example. In database, we can have more uniquely divided data. Or for another example, tweets organized by hashtags only. In unstructured data, that's basically the social media data, which is a set of different media posts or emails or videos or images, speeches, sound, and so on. It's quite messy comparing to the other two, but it has a more information than them, which is why it can be given to deep learning only, but not machine learning. There's another thing, it's quite new relatively, but you shall know it if you want to research more into it. It's called generative adversarial networks. It is a subset of deep learning, and so far it's mostly used in research organizations, and the most practical use case I have found for it is super resolution. Super resolution is a problem in which by the way, the shortcut for this name is called GEN. The GEN takes an image. For example, it has resolution 256 by 256, and it gives us an output, the same image with a very high resolution of full HD, for example, 2048 by 2048, and it's quite clear. It wouldn't be blurry or anything. There's a fun website I found. It's called thispersondoesn'texist.com, in which it was a show off of the authors of some paper that they were using GANs in it with. And they are showing you pictures of images of humans, but actually this human face is just generated using GANs, and it's not a real person image. As you can see, the two examples here are very great. You wouldn't suspect that this is fake at all. But in this image, as you can see here, this part doesn't make sense. I don't know what this exactly. It seems like a part of head here, but this part is not clear at all. Of course, because this is fake, as we all know, but it's still pretty amazing. There is also another application called Reface. If any of you knows it, you can insert some image for yourself and select videos on the application, and it would blend your face into the characters in the video, and it would seem totally realistic. This is all an application of GANs, and this is an application or a subset of deep learning, but it's quite heavy. Now let's talk about the difference between data science and data analytics or analysis. Basically, the difference between data science and data analysis differs in what you are trying to do with the data. In data science, which is more into the area of artificial intelligence, you are trying to find some insights from a large amount of data. Basically, if you are a data scientist, then you are probably dealing with unknown data. For example, you have a large set of data and you are trying to make sense of it and give us some prediction using this data. So it's basically an advanced technique to predict answers from uncertain data, so that you can get to some solutions based on the business applications that you are working on. Data scientists also can automate their machine learning algorithm, and by automation I mean that it just runs by itself. It can take the input and improve itself and give you the prediction right away, and so on. And it can deal with both structured and unstructured data. While in data analysis, you are just trying to show what this data mean for others, but you don't need to get to the prediction. So it's basically a process of cleaning or transforming, manipulation the data, visualization, and so on, such that you can reach some insight, but not prediction. You have to understand the difference between both. Data analysis is quite simpler compared to data science. If you are trying to work as a data analysis, or the skills that you need to know, it probably uses tools like Python or language. These two are the most popular. SQL, you would need it for dealing with the database, and some visualization tools and the statistical analysis. This is a comparison between them. As for the mathematical background that you should need in both data analysis and data science, data analysis you need some foundation of math, basic foundation, but you should know statistics pretty good. In data science, you need more advanced statistical analysis and predictive analysis too. In programming, data analysis, it is sufficient that you know or Python SQL without having to program advanced OOP codes in it, like in classes and different files, importing and so on. They mostly don't need these things in data analysis, but you need them in data science. As for the software and tools, this program is used for some visualization, Excel, and other business intelligence software. There is a popular Microsoft program for data analysis. I don't remember its name right now. Oh, Power BI is in business intelligence. This is used for data analysis too. In data science, you need to know TensorFlow and PyTorch are popular modules in deep learning. So there are modules in Python. MySQL, Spark, and Hadoop are used for dealing with the data, with a large amount of data. Other skills that you should know, here obviously you need some analytical thinking and data visualization, but in data science you need to have a foundation of machine learning and data modeling. This is a fun image I found. That if you have the basics of computer science and you wanted to do something for the business domain, then usually just need traditional software or traditional programming. The mix between computer science and math and statistics gives you the machine learning, while the mix between math and statistics and business domain is the data analysis. Data science is actually the combination of these three altogether. You need the math and statistics, the computer science skills, and you give it to the business or domain expertise to give us some predictions that we can use to solve our problems. Here is another image that shows the relation between data science, machine learning, and AI. Starting from the data, we are going to dive into the deep learning, then we extract the features ourselves, and this could be unsupervised learning if we don't know the output of the data, like in clustering technique. Then this data, you can use supervised machine learning technique to give us some predictions. Here is the machine learning. This arrow shows that if you didn't extract the features yourself, then you just give the data to the predictions right away, which is deep learning. In machine learning, you extract the features yourself, and then you get the predictions. But if you are just using this data and the extracted features to get some insights, then this is data analysis. And this common part falls into the artificial intelligence bubble. Finally, these predictions in some cases can be used to do some actions. If you are predicting, for example, the direction that a robot should go into, so you are mapping it into an action that the robot should do. This is the phases of data analysis. If you are trying to make some data analysis on the data you have, then first you gather the data yourself or using any technique. After you collect this data, clean it from any messy data, you get the analysis that you want and you're trying to make sense of it, which means that data interpretation, so that you can show it using the interpretation and visualization to other people in the business that probably aren't data analysis. In data science, you have the data in what we mean by data discovery, that you are trying to understand it and make sense of it. And you prepare it for the model that you're building, because each model that you build probably takes the data in some format. You can have the data as images, but you build the model to take some values, for example, the values of the pixels or anything. So in data preparation, you fix this mapping. You plan how your model is going to be like and build it. Then in operationalize, you give the data to the model and train it and so on, using analyzing performance and updating. And finally, you get the result and you communicate it to other people that you have in the organization. Now we're going to show some different practical use cases that we have in our life. These are examples that we all know. Smart assistants on our smartphones, like in iOS, Apple phones, we have Siri, and in Windows, it's called Cortana, as far as I remember, or Google Assistant. All these smart assistants depend on some basic machine learning models. The first of them is for voice recognition, so that when you speak to it, it can recognize your voice, first of all. Then after it recognizes your voice and maps these voice signals into words, we want to understand what these words mean. This is called the natural language processing, or NLP. It makes sense of what you are saying and maps it into actions that it should do. For example, if I told it play some song, so it understands what song I want to play and on what application, and runs this song, and so on. Another example is used in many companies now is smart securities, or in our laptop or smartphones. When you have the lock using face recognition or voice recognition, it recognizes your face apart from anyone else. This is also an application of deep learning specifically, or computer vision, in which it can recognize the face. Face recognition, of course, isn't a computer vision application, but it falls into the deep learning pool. It's also used in agencies or factories, so that when you enter, it recognizes the employee right away. Another example, the applications like Instagram, Snapchat, and even B612, if you know it, it recognizes the face, so that when you apply some filter, like adding some cat nose on your face, the application should know where your nose lies exactly, and when you move your face, it moves with you. This is applications of computer vision, which again is a part from deep learning. Another example is smart traffic. It's used in some countries so far. I haven't seen it here in Egypt, but I know for sure it's used in Canada. You have on each traffic or corner, they have cameras which can detect cars moving, and if any car is violating the traffic laws, and if it did, like moving in the opposite way or past the stop sign and so on, it detects the license plate on the car and extracts the car license number and stores it in their system right away. The last example here is cancer detection, used heavily in medical examples, in which we can give some image like this into the computer, and it can tell us where the tumor or cancer is in the image. As you can see here in the image, it's of a brain, and it extracted where the tumor lies exactly. We can discuss this in the end. Last topic we're going to discuss is the career jobs in AI recently. I guess most of us know that since the recent few years, there has been a significant increase in the jobs of data scientists and machine learning engineers. Data science has increased by 11.5, machine learning 30, and researchers in AI has increased by 27.5. It actually spread even more since the COVID pandemic. I guess it's obvious for all companies, not related to AI only, that most companies now hire working from home engineers, either the scientist or not. This, I recall, I got it from LinkedIn. It shows the emerging jobs in the years from 2012 to 2017. As you can see, the most emerging job was machine learning engineers and data scientists. Most of these actually are computer science field. Here is big data, full stack. I guess the others are other field. Okay. This statistics shows revenues of the AI field in the market, which means how much they invest money-wise into the field. Here we have in 2012 around 24. I recall this was in million. Yes, 24 billion and 161 million. And it is expected that it would increase almost the double or even more in the following 3 years only. These companies, if you are searching for jobs, and you should know that this is the most companies that hire AI engineers. Most one is Amazon, and we have Google, Microsoft, Nvidia, Facebook. These companies are all quite popular. You have IBM here, and so on. I don't recall who said this quote, but I believe it's true, because as we advance in the years, we would rely more into the machine learning and AI in our life. This is the most popular AI jobs I have found on the internet, searching on LinkedIn and so on. Machine learning engineers, data engineer. Data engineer, by the way, differs than data scientist in a small part, that you have to be expert too in dealing with clouds like Amazon Web Server and Azure for Microsoft and so on, so that you are dealing more with the data itself and how it manages or runs in short time on this cloud. So it is a mix between data science and basically databases, techniques and so on. Deep learning engineer is obvious. Computer vision is a part of deep learning, but sometimes companies specify that they want computer vision engineers because all their applications are on computer vision. AI researchers, if it is in a research company. Cloud computing engineer, again, deals with clouds more. ML ops is actually quite similar to DevOps, if you know, but they deal with machine learning models instead. Business intelligence engineer is more into the field of business and banks. I always find the banks looking for business intelligence engineer. Big data engineer doesn't differ a lot than data engineer. NLP, again, is included in deep learning, and we know the rest. Analysis. Among the Middle East, by the way, I have found that United Arab Emirates is the most paying in AI jobs. I guess worldwide it wasn't USA, but I don't recall which country it was. But again, it's from the most paying jobs. But if all the audience here is software engineers or computer engineers, then it wouldn't differ that significant. I mean, it's the most paying jobs in comparison to other fields that are not related to computer science at all. Most important thing that you should know, or skills that's most needed by AI jobs: proficiency in Python. Following by it is C++, but Python is most needed. You should know or have a good foundation of mathematics, linear algebra, because you deal with a lot of matrices in computer vision and deep learning. Differentiation, because the physics of deep learning depend on differentiation heavily. And finally, probability and statistics. You should know the most popular AI modules, Python modules, Pandas, NumPy, TensorFlow, OpenCV. Understanding machine learning foundations, methods, and models. The same with deep learning. if you are trying to specify into computer vision, then you should have a good foundation of image processing and computer vision as their concept and tools. And if you are diving more into NLP, natural language processing, then you should know the concept and models. MLOps is, you wouldn't need it in the start, but if you are trying to promote yourself to a senior data scientist, for example, you should know all the basics of MLOps. Okay.
Thank you, Mrs. Radwa. I really appreciate your presentation. It was very rich and interesting. Thank you for sharing your knowledge with us.
Thank you. Okay.
So it's time to take the audience questions. Please feel free to ask anything you want. Write them or on the chat, or open your mic and ask. I have a question.